This
Madam.
conference will now be recorded.
Very good evening, students. Welcome to this PYQ discussion session. We have been discussing JEE Mains papers. So today I have got few questions from JEE Mains paper 2021, shift 1, July 20th July paper. So let us try to solve these questions one by one. So the first question says, in the reported figure, that means this one, heat energy absorbed by a going through cyclic process. Sorry, heat energy absorbed by a system in going through a cyclic process is dash by joule. So you have to answer this or fill this dash by integer, positive integer number. So let us see this process. This process is a cyclic process. So you know, first law of thermodynamics, d delta q is equal to delta u plus delta w. Okay, in cyclic process, what happens if I start from here, you know, all the way you go like this. Suppose this is point B and you come back to the A point. Okay, when the state is same, since internal energy is a state function, it is not a path function. So, and also all the thermodynamic conditions are same, like temperature, etc., are same when it comes back to the same point. So what will be zero is the internal energy change. Change in internal energy will be zero. That means there is no change in the internal energy. So the first law of thermodynamics actually turns out to be dq is equal to dw. Delta w. Delta w is actually work done. Work done during this. Okay. So the heat absorbed, heat energy absorbed by the system is actually becoming equal to work done. And as you know, the work done is actually calculated from the area under PV curve. So this is volume in liter, and this is in kilopascal. Okay, so ultimately you have to find out so this delta q is actually will be equal to the area of this circle. Okay, so this will be area of this circle. So what is this area of the circle? We know this area of circle is actually pi r square, right? Pi r square. But you look here, this circle graphically, when we find out, we'll be doing this. So instead of writing r square, we'll write this as pi r1 and r2, pi r1 dot r2, like this. So where r1 I have taken this, the radius in the horizontal direction, and this as vertical direction, r2 as vertical direction. So look, this r1, so pi r1 is actually 20 liter. I have to write in, okay, 20 diameter is 20 by 2, that into 10 to the power minus 3. Okay, liter I have to convert in this. Okay, and I have r2 in the vertical direction, that is also 20. That means, you know, 20 by 2 into 10 to the power kilopascal it is, so 10 to the power 3. So this is P, this is V, so this will give you the work done or the area of the circle. So what you get? 10 into 10 to the power minus 3. Here also 10 into 10 to the power 3. So what I get, this and this cancel out and I get 100 pi. So here this is in joule, so here it will be 100 joule. Okay, so this is what is the answer for this question. Now let us go to the next problem. This problem says the amplitude of wave disturbance propagating in positive x direction is given by this. So this is at time t is equal to 0. So y at time t is equal to 0 is given. So y at t is equal to 0 is given as 1 plus 1 over x square. Okay, again the same, the amplitude of the disturbance at any time t is equal to 1 second is excuse me, is given by 1 plus 1 over x minus 2 whole square. So here x and y are in meter, that means distances. The shape of the wave does not change during the propagation. Okay, during the propagation of this wave, suppose the shape of the wave is not changed, then what will be the velocity of the wave in meter per second? Look, see, these are actually amplitude at any time. If I just say, let us take some sine wave itself, then it goes like this. Okay, like this it goes. Oh, all right, so I have taken only for this. See, if the amplitude, see at t is equal to 0, if I say this is t is equal to 0, okay, the amplitude is given, so this is the amplitude and the shape of the wave is not changing. That means, you know, the shape is not changing means the amplitude are same, right? That's what we can say actually. All right, okay, so one more point, you look here. So this is in time t is equal to 0 and this is, see, generally displacement will be like, you know, this point, if I say this point at t is equal to 0 is x, or any point as such, you take this point at t is equal to 0, this is the displacement at x. Okay, so this point, you know, will be by phase, it will be actually ahead of the point. Suppose if I say this point is at this point, if this is t is equal to 1 here, so if I say this is p point and this is q point, so q point will be actually behind by phase. Okay, and how do you write that? You know what we write? Generally we write this is equal to x minus vt, y is equal to x minus vt, where v is the velocity of the wave and t is the time. So if I write in terms of, see, in terms of the wave given here, I can actually write actually write according to the given shape or all. If we write y is equal to 1 plus x minus vt whole square, if I write like this, see the first one will be satisfied. See at t is equal to 0, y will be 1 plus 1 over x minus vt whole square. So t is equal to 0 means this one. Okay, if I write at t is equal to 1, okay, at t is equal to 1 and then compare. So let me write, so this should be the general formula for the displacement of the, so this is the general formula for the displacement, say. Okay, this is the general formula or general equation, general form of displacement, let us say, form of displacement, general form of displacement. Okay, from where I have got from this two itself. Okay, if we put t is equal to 0, we'll get this one. If we put t is equal to 1, we'll get a form like this. Now if we compare this two at t is equal to 1, so let me write it here. See what we get, sorry, 1 plus 1 over x minus v whole square, which is exactly equal to 1 plus x minus 2 whole square. Okay, 1 plus 1 over x minus 2 whole square. Okay, if you compare these two, or from this equation, you can be able to get v is equal to 2. Okay, this is 2 meter per second. So this is how you can do. Another way I can tell you directly, you can see from here at t is equal to 0, it is given as 1 plus 1 over x square, and some other time it is given at t is equal to 1 second, it is given as 1 plus 1 over x minus 2 whole square. That means the wave has shifted to a point that is 2 comma 0 point. Along the x-axis, positive x-axis, it has got a displacement. Okay, so wave displacement from directly from this equation, you can say the displacement of the wave. Okay, displacement of the wave has become how much? So d is equal to 2 along the positive x direction, 2 meter per 2 meter. And you know, we have to find out then velocity of the wave. If it is v, then d by t. T is 1 second, so it will be 2 meter per second. Okay, so this is how also we can solve this problem. So what will be the answer for this? The answer will be 2 meter per second. Okay, so the answer will be 2 meter per second. Let us write that here, 2 meter per second. Okay, all right, let us go to the next problem. So this problem says, sorry, in an LCR series circuit, okay, LCR series circuit must be connected to some AC voltage source having voltage V. Let us write that. Okay, so here the question is, in an LCR series circuit, an inductor is 30 millihenry, then resistance is 1 ohm, and capacitance is not given. Connected to an AC source of angular frequency is given. So angular frequency omega of this battery or the source is given, that is 300 radian per second. The value of the capacitance for which the current leads to the voltage by, see this is LCR circuit, and here see the value of the capacitance for which the current leads the voltage by. See the phase angle is given, current leads the voltage by 45 degree is 1 over x into 10 to the power minus 3. So the question is actually the capacitance, the value of the capacitance is not given, but it is seen that if the capacitance value of the capacitance becomes 1 over x into 10 to the power minus 3 farad, then the circuit will lead, sorry, the current will lead the voltage by, current will lead the voltage by 45 degree angle. That means the phase angle is given. So in case of LCR series circuit, phase angle, you know how do you calculate phase angle? Like this. Okay, so R goes with the current. Okay, this goes like omega. So this will be along the R or this, yeah. So VL and VC, they will actually be perpendicular to each other. So I can just draw this like this. So this is phi say. So this is omega L. This is omega C if you can write. Okay. So omega L. Actually, this is okay. Okay. Anyway, so what I'm trying to say is that the tan phi will be y by x. What is that y by x here? So xc minus xc, you know, this is actually directly we can write. Okay, so we can write directly even without drawing this kind of figures also. We have already learned this in case of xl minus xc divided by r. So this is what we know, right? So this is given tan phi 45 degrees. So phi is 45 degree, phi is 45 degrees. So we know tan 45 degrees is equal to 1. So r is equal to xl minus xc. See, r is given. See, this L is given. Then we have got omega here. So I will be able to find out what is xl. Let me find out. See, xc will be actually xc will be xl minus r. xl minus r. So xl is omega into L, and this is r is actually 10, sorry, 1 ohm. See, the resistance is a 1 ohm. So the whole thing will be actually in ohm only. So omega is 300 radian per second. So this is actually angular frequency only. So this is fine, and this is 30 into 10 to the power minus 3 Henry minus 1 is equal to, this is in ohm. So we get, see here I can write this is 1 over omega c is equal to this term, right? This term. Anyway, I have to do this thing like this to this one, that will cancel each other. So I have 3 3s are 9. Okay, then it will be 8 ohm. Okay, so you know this is 1 over c. This will be omega into 8. So this is 300 rad per second. Okay, so this will 300 rad per second. So this will be this much. This will be in farad actually. Okay, farad finally. I see this will be in actually. Okay, fine. So this is, yes, yes. So I have got 1 over c. Then I have to get c. C is equal to 1 over 2400. This will be in farad actually. This will be farad inverse. So this will be farad. Okay. Okay, somehow I have got some. Okay, I see. Here actually xc minus xl, if we do, that is okay. I'll just redo these things, guys. So I have done a small mistake over here. So tan phi is equal to xc minus xl. Okay, this is the thing, divided by r. So phi is 45 degrees. So I'll write from here r is equal to xc. So guys, here xc will be is equal to x, this is xl, r plus xl, and xl, as you know, this is 1 ohm plus 300 millihenry xl. Xl means omega into L. Omega is 300 and L is 30 into 10 to the power minus 3. Okay, this will give you guys, see, this will give you 10, see, 9, 1 plus 9, this is an ohm, so this will be 10 ohm. So once we get xc, we know this is 1 over omega c, and that is equal to 10. So this will be c will be 1 over 10 omega. Omega anyway we know, so let me write this as x. So this is 10, omega is actually 300. 300 rad per second. Alright, so we can write here 3 into 10 to the power 1 over 3 into 10 to the power minus 3. So then if I compare with this, then you know x will be equal to 3. Alright, so this is the answer for this question. Okay, so it is 3. Let us go to the next problem. So this question says a rod of mass capital M and length capital L lying on a horizontal frictionless surface. So situation is something like this. So frictionless horizontal surface. A particle of mass small m along the traveling along the surface hits at one end of the rod with velocity u in a direction perpendicular to the rod. So there is a particle of mass small m which hits one end. So this has got mass m, right? This has got mass m. Let us say this is the center of mass of this rod, and this has got a length L, as you see. So this has got length L and mass m. So there is a small mass. So this was at rest initially, and there is a particle of mass small m which is moving with velocity u and hits the rod at one end of the rod, okay, in a direction perpendicular to the rod. The collision is completely elastic. Completely elastic means E is equal to 1. I can take coefficient of restitution. Okay, this I can take as 1. After collision, the particle comes to rest. That means this is coming to rest. The ratio of small m by capital M is 1 by x, but the value of x is dash. Okay, so this is what is the question. So I hope guys you have understood this question. So what we will do, first of all, see this particle is in motion initially, and there is no force actually, there is no net force acting on this object. So there is no net force. That means external force is 0. So if there is external force 0, then what I can say, I can say that there will be momentum conserved, right? Momentum will be conserved. Linear momentum conservation I can write. See, initially this rod was at rest, but this was moving. So applying momentum conservation, I can write m small m to small u plus 0 is equal to, finally the rod is completely okay. So so what will happen, so because of this, see, the rod will rotate with certain velocity, angular velocity, let us say that is omega, and it will move also with certain linear velocity. So it will have two motions, since it is actually hit. See, it was hit by it was hit by the small m at the end, one end. So it will have two motion, one is translation, another one is rotation. So translational momentum, that is linear momentum conservation, says this will be m into v, and c, the velocity of the small mass after collision will be 0. That is what we have got. So this v, that means the velocity after linear velocity of the rod after collision is small mu divided by capital M. So this is actually the speed of the rod. Now see, if I see after collision, if I consider there is no external torque, so I can conserve the angular momentum also. So angular momentum conservation means moment of linear momentum, okay, see, initially the moment was how much, mu, okay. So moment of linear momentum, see, about this point, so this is actually L by 2 center of mass, and this is L by 2, mu L by 2, this is moment of linear momentum, that is equal to actually the angular momentum. Moment of linear momentum means angular momentum. So angular momentum is equal to I omega. If omega is the angular frequency of the rod, okay. So I have got this equation as well. See, I can write this I. See, if I find out moment of inertia of rotation, see, rotation. Let us consider the rotation of this rod is happening about the axis, which is passing through the center of mass and perpendicular to the rod. Okay, that is actually given by ml square by 12. Okay, ml square by 12. So once I get this ml square by 12, and what is this? This is omega. So from here, I can find out omega divided by 2 capital M L square. So this is 6. So 6 small m u by capital ML. Okay, 6 mu by capital ML. So let us give the equations some name. This is equation number 1. This omega is equal to 6 mu by 6 ml, sorry, ml, m into L. Okay, this is say equation number 2. Now this, when you consider, okay, the conservation of momentum. Now I'll go for this coefficient of restitution. So relative velocity of separation divided by relative velocity of approach. Relative velocity of separation is how much? It is going with velocity v, and velocity of approach, okay, so I think there is another velocity which is coming from the angular rotational motion, that is omega L by 2. So approach, relative velocity of approach is this much, okay, and this side is actually 1. So u will be equal to v plus omega L by 2, okay, and further u is equal to CMU. Excuse me. So far we have got this one, okay. Up to this, let us say this is equation number 3. We have got a relation between u and v, and also omega is equal to 6 mu by ml. Let us put this here, okay, let us put it here. Omega is equal to 6 m, this is plus sign over here, 6 m, sorry, 6 small mu divided by capital M into L, and see there is L here, this is 2 here, okay. So this will be 3, this L will cancel each other, so ultimately what I'll get, capital this will be V only. If I have written capital V, so capital V and small v both are same in this case, V plus 3 mu by capital M here, okay. So this is what we get as u. From here actually we'll be able to get u also in terms of v, right? Then we can compare actually, okay. So this is u. Now look what we get from here. See, if we put the value of v, V is actually mu by capital M. Let us put this value V from equation number 1. So there is mu by capital M, and this is 3mu by capital M, which is actually 4 small m u by capital M. So this is actually, this is equal to u. Then look what we get. This u cancels each other, and finally what we'll be getting? So you will be getting capital M by small m is equal to capital M by small m is equal to 4. Here what ratio we have to find out? Small m by capital M. Small m by capital M. So small m by capital M is equal to 1 over 4. So here if we compare with x, so it will be 4. So small m by capital M ratio is 1 over x. So x is 4. So here x is 4. So this is the answer for the question. Now let us go to the next problem. So this problem says a circular disc reaches from top to bottom and of an inclined plane of length of length capital L. When it slips down the plane, it takes time t1. Let me draw this inclined plane something like this. Okay, so this has got certain angle, say, with the horizontal, and this is actually inclined plane, and it has got a length. Okay, this has got a length capital L. It slips, so a disc, okay, it can rotate, it can slip, so depending on situation. So let us first find out for translation motion. So when it is slipping, okay, when slipping, so what we get when slipping? When the disc is slipping, that means there is a translational motion. So what will be the acceleration for this case? The acceleration will be a1 is equal to g of sine theta. Okay, so that will be the acceleration along this plane. So then suppose it starts from rest, okay, is equal to 0, then what will be v at this position? I know the length, okay, I know this acceleration, so I know s is equal to ut plus half at square. So u is 0, so half at square, a1 t square, half a1 t square. Let us write this. So here u is equal to 0, half at square, where a is a1 here. So I'll write u is equal to half a1 means g sine theta into t square. So this t is actually t1 given. So I have found out t1 by t2 ratio. Let me write then what is t1. T1 is equal to t1 square is equal to 2u by g sine theta. 2u by g sine theta. So this is what will be the t1 square. Okay. Now if we want to write, okay, I think there is no u velocity here. U is 0. So that is s is equal to half I'm sorry, this is S is equal to half a t square. S is equal to, this is actually S means L here. This is L. Okay, so this is T1 square. Now, if we consider the rolling case, then I'll get T2. Consider rolling. In case of rolling a disk, you know how do you get the formula for the acceleration, that is A2, let us say. So that A2, so A2 is equal to G divided by, so let us consider the rolling case. Consider rolling motion of the disk. So that the acceleration for rolling motion, you know that G sine theta. This you have to either derive or you have to remember. This formula is very standard formula. So this is moment of inertia divided by mr square. Okay, so this is a disk, right? So I will be moment of inertia about its own axis, that is mr square by 2, right? So this is also, let us say, capital M only. So G sine theta divided by 1 plus mr square divided by 2mr square, and so this goes off. So you get 2g sine theta by 3. Okay, this is the acceleration. Now if you have this acceleration, how much will be the time to cross this distance L? So T2 square will be equal to similar formula, S is equal to ut plus half a t square. So here I'll write T2 square is equal to S by, that is 2S by, so 2L by, so 2 into L by, okay, better to write this, half a 2 t square, T2 square is equal to L. So I have to find out T2 square. So 2L by A2 square, A2, sorry, A2 only. So 2L by A2 is actually 2G sine theta into this is 3. Okay, so this is 6, sorry, this is 3L by G. 3L by G sine theta. 3L by G sine theta. This will be A2. Sorry, T2 square. Let us then find out. So T1 square, what we have got? We have got T1 square here, and let me write T2 square here. So T2 square we have got 3L by G sine theta, right? Let us write this here, 3L by G sine theta, G sine theta, and T, we have to get the ratio T1 by T2, so this whole square is equal to, so T1 square is equal to 2L by G sine theta, T2 G sine theta by 3L. So this will cancel each other, L cancel each other, so 2 by L. So T1 by T2, let me check whether the T2 by, okay, sorry, I'm sorry, this will be, so this ratio actually you have been asked to find out T2 by T1. So this is actually T2 by T1. Okay, T2 by T1 ratio is given as, see, this will be root over 2 by 3. So see, I'm sorry, this is 3 by 2. T2 by T1 will be square root of 3 by 2. So square root of 3 by x, I can compare with this. So this x will be equal to 2. Okay, x is equal to 2. Now let us go to the next problem. So probably this will be the last problem for this session today. So this question says a butterfly is flying with the velocity v is equal to, so let me write this, v butterfly, okay, with respect to some rest frame of reference, that can be rest ground, maybe that may be wind also. Okay, so what we have to find out, okay, let me write this. This is some from some rest frame. Let me write this as ground itself. Okay, this is the velocity of the butterfly is, so a butterfly is flying with the velocity 4 root 2 meter per second in northeast direction. You can see this is the northeast direction, which makes an angle 45 degree with the east. Okay, and similarly 45 degree with the north also. Okay, and wind is slowly blowing at 1 meter per second. So wind velocity of wind, so this is with respect to ground, which is given as 4 root 2. See, if I just break the component into this, suppose this is positive I cap, this is positive x cap, then I get root 2 I cap plus 4 root 2. So there will be of 45 cos of 45 here along the I cap direction. Let me get a longer space, greater space with respect to ground, 4 root 2 cos of 45 degree angle I cap plus 4 root 2 sine of 45 degree angle along j cap direction. And see, the wind has velocity along minus j direction, that is 1 meter. Okay, 1 minus j cap along the south direction. Okay, from north to south, from north to south. So you have to find out the resultant will be along some direction along this way. Okay, along this way. So this will be the resultant. Okay, let us find out the v resultant. Resultant will be actually, see, resultant vector will be So VBG plus V wind. Okay, this will be the resultant vector, right? So just forget about this thing. So VBG G for ground and V velocity of the butterfly with respect to ground, and this is also with respect to ground only, wind. So I have got, see, 4 root 2 cos of 45, that means it is 4 I cap plus 4 j cap and minus of this j cap. So what we get? 4 I cap plus 3 j cap. So this is the vector, resultant vector, okay, velocity vector, and magnitude of that we have to find out. So magnitude of this will be square root of 16 plus 9. So this will be 5. Sorry. Okay, this is actually in 1 second. So this is velocity is meter per second. Okay, this is meter per second. So this is the velocity. What will be the displacement? Okay, displacement will be in 3 seconds. That is what we have to find out. So displacement will be, see, this is actually constant velocity. So S is equal to Vt. So V is 5 and T is 3. So this will be 15 meter per second. Sorry, this is 15 meter. I'm sorry, this is 15 meter. This is actually 12 meter in the option. Okay. So this is what we get. So the first option is the correct answer for this question. Okay. So with this, we'll stop it here for today. Thank you for your patience.